So guys, if you see, we have a one company that is take example of the Network Home, and Network Home has a two branch office, right? So not branch office, we have a one is a headquarter branch in the Delhi, and we have a branch office in the Bangalore location, right? Okay. Now try to understand if I want to provide the communication between these two locations, right? If I want to provide the communication between these two locations, what we have to do? We need to take a help of the ISP, right? And through the ISP, I can exchange my all information. Let's take example. I'm going to run with the any routing protocol of them, GRP, okay, or any BGP or anything. So what happened? R1 has to share the own information to the ISP, and R2 has to share the own information to the ISP, right? So first of all, according to the RFC 1918, we have a two types of IP addressing, right? The first we have a public IP address, right? And second we have a private IP address. According to the RFC 1918, what happened? We have a two types of IP. One is the public IP, one is the private IP. The main difference between the public and private, the private can be duplicate, right? It can be duplicate and it's not routable. It's not routable. So you cannot share this information. The first issue is that in the LAN information, what happened? We are going to use the all private IPs. In the LAN network, we are going to use the all private IP address. On the WAN side, I'm going to use the public IP addressing, right? So the first thing is that this route is not routed. We cannot share this information to the ISP. We cannot share this information to the ISP. This information will never shared to the ISP because ISP cannot treat this, cannot route this packet. Sorry, cannot route this route over there. ISP cannot route because this is my private, and private IP address is not routable. This is the first issue is happening. Second issue, if I'm going to talk about, take example, still if you have a public IP, take example, I have a 1.0.0.0.0/8 information on R1 and 2.0.0/8 information on R2. What happened if you're going to use the public IP in a LAN side? So in this case, what happened? R1 need to share all this information to the ISP, and R2 will need to send all information to the ISP. It means ISP is going to maintain this LAN information, right? And what is ISP? ISP is totally untrusted network. ISP is totally under, because on the untrusted network, what happened? We have some good people over there, right? And we have some bad people over there. And what is the bad people is going to do? In this case, they can perform any kind of attack in your network because you are sharing the complete LAN information. You are sharing the complete LAN information to the ISP. See, the first issue is that if you're going to use the private IP address is not routable because we cannot share this information to the ISP, right? This is the first case, first issue happening. Second case, if you're going to use the public is not free. You have to pay some amount of money. First of all, you have to pay some amount of money. But still, if you are a very rich person, you can pay the amount of money to the public IP addressing. But in that case, what happened? You're going to share this all information to the ISP because we are running with the any routing protocol of the EHGRP. So through the EHGRP, we can exchange the all route information, right? Through the EHGRP, we can exchange the all route in 1.0.0.0, 1.0.0.0. This guy is going to say the own information 2.0.0, and this guy is going to say the own info 2.0. So what happened? ISP is going to maintain all this information in the routing team, and that's a totally untrusted network because ISP is like a public road. We can say that on a public road, what happened? There is chance of accident, right? On a public road, what happened? Every person is going driving a car over there, right? Same thing. What happened on a public internet? We have some good user or we have some bad user, and what bad user is going to do? They can perform any kind of attack in the network. It is something like that. You are setting the complete LAN information, right, to the ISP. That is not a good way. That's not a scalable actually, right? For the security point of view, it's zero. There's no security is happening because you are sharing the own information to the untrusted person, right? And second thing, if you have a one way, guys. CCIE. Another thing is that first of all, you are going to send all information to the ISP, right? Another thing is that can you see that there's no security is happening? And second thing, if you have a private network, this private network is not routable. Hey, you have option, you can implement the NAT. That is a different thing, right? You have, if you can implement that, you can still provide the communication, but you cannot share the own LAN information. You cannot share own LAN information to this guy, this branch location. From headquarter, right? From headquarter Delhi, we cannot share the own LAN information to the branch, Bangalore branch. And from Bangalore branch, we cannot share the own LAN information directly to the headquarter. If you not do that, what we have to take? We need to take a one private connection. If you don't do that, you can take a one private connection. We can take a lease line connection over there between this guy to this guy. That is a very cost effective solution. It's very costly. It's very costly because you're making a own road over there. It's something like that. You are making a own road from headquarter Delhi to the branch office Bangalore. So what, and again, the cost comes in the picture. And if you're going to take a private connection over there, you have a limited speed, right? I'm going to take a lease line. So what happened? I said, okay, my this speed is 10 Mbps. Take example. But right now, what happened? We have a less amount of user. But take example, if your user will be incremented by the next year, maybe the 10,000 user is sitting over there now. So for the 10,000 user, what happened? This speed is not sufficient, right? I have to increase this guy because of 100 Mbps. So again, what happened? You again change the link over there, right? So the first issue with the cost and second issue with the speed. We cannot put the one direct cable between this guy to this guy. Again, what happened? Take example from this location to this location in the middle of the part. In the middle of the part, what happened if this link is breakdown, right? Can we perform the troubleshooting over there? No, it's very hard. So what we can do to exchange my LAN information from this side to this side directly from here to here, right? Without involving the ISP, we can exchange my all LAN information from here to here. I just need to create the one overlay network. I'm just going to create the one overlay, or we can say that I'm just going to create a one logical topology, or we can say that I'm just going to create a one virtual topology. Yep. I'm just going to create a one tunnel between this source, or we can say that from headquarter branch office to this location. I'm just going to make a one logical connection, right? I'm just going to make a one logical connection from this guy to this guy. And through this logical connection, right? Through this logical connection, I'm going to exchange my all routing information, all the LAN information. So over this ISP, right, I'm going to create a one logical connection. This logical connection is known as a tunnel. And we can achieve this thing by using a VPN. VPN, what allows the VPN is similar to the virtual private network. What is saying that the name is saying that virtual, right? Virtual means what? It's present, but you cannot see that. It's a logical connection. It's a logical connection. What I'm going to do, I'm going to create a private network, right? So between this headquarter Delhi to the Bangalore branch office Bangalore, I'm just going to create a one private network over the ISP. So we can say that VPN, it is used to create, or we can say that it is used to provide the connectivity between two or more branch office sites. We can say that over the public network. That's the meaning of VPN. So VPN is nothing but it's just going to make a one logical connection. So this is my underlay topology, right? This is my underlay topology, right? What will be my overlay? So after doing this thing, what happened? My topology will something like this. Router number 1, router number 2. That's my branch office or the headquarter office in Delhi. And we have a branch office in Bangalore. Now we have a router number 1, we have a router number 2, and we have some LAN information over there. /24. We have a LAN information /24. The same time we have a LAN information over there. So this should be a 3.0. This should be 4.0. And now we have a connectivity look like this. Or overlay network. So this is my logical network or virtual network. We can say that makes a logical connectivity between over the public network, right? So now after making, so you can see that this is my underlay topology, right? And this is my overlay topology. So after creating a VPN, right? After creating a VPN, my network will be converted from here to here, something like this. So we are just transfer my topology from this topology to this topology. Can you see? Now we have an ISP. In the ISP, what happened? In the ISP side, we have a multiple sort of maybe the 50 routers. So maybe the headquarter Delhi and branch office Bangalore, right? They have connectivity between the 50 routers, right? Now what happened? They have a direct connectivity. So do I need to make any kind of physical connectivity over there? No. Do I need any kind of physical cable? No. I don't need to require any kind of physical cable. So in this section, which protocol I'm going to use to run? Maybe OSPF, BGP, anything, right? Let's take example. I'm going to run with the OSPF on an underlay network, right? On an overlay, what happened? I can implement the PHGRP. So we can say that, or we can do like this. 1 minute. We do this guy, and let's put it down a little bit so I can explain. Way this guy, and this guy. Can you see now? On the top of the underlay, right? We have a overlay network. So this is my base, we can say that. And this is the actual topology that we are getting after the creating the VPN. So this is my actual topology, this is my original topology, and this is my logical topology or virtual topology, we can say that we are going to achieve through the VPN. And this is the base one. Clear now? So basically what happened if this topology is going to, if this topology is existing, then we have this topology. For example, if this topology is no more, for example, if this link goes down, right? Take example, if this link goes down, my complete overlay will be down. So this overlay is totally existing on the underlay. So we can say that on the top of on the top of the underlay, we have a overlay network, right? Because we need to have this one underlay. If the underlay is not working fine, you cannot ever achieve the overlay network. This is my pure logical topology. This is my pure logical, 100% logical topology, this guy. And this is my pure 100% physical topology. So this is known as the underlay network, or this is known as the overlay network. And this thing we are going to achieve via the VPN. So what VPN is going to do? VPN is just going to provide a logical connection between the sites over the public network. It used to provide the connectivity between the two or more sites over the public network. So this is my public network, and that's going to provide the connectivity between the site 1 and site 2 over the public network. So we can run the OSPF on the we can run the any of the routing protocol on the OSPF, right? It's totally independent by this guy. So overlay network is totally independent according to the routing protocols. So now we can exchange all this routing information through the EIGRP. So R1 will say the own information to the R2, all this information 10.1.1.1.0/24. And this guy is going to say the own information 10.1.3.0/24. So in the VPN, we have multiple types of VPN. We have in a VPN, if you go, we have a layer 2 VPN and we have a layer 3 VPN. We have a layer 2.5 as well, as that is known as the MPLS VPN, right? We have a layer 2, which I'm talking about. We have a frame relay, right? And we have a Q and Q tunneling. That's also part of the layer 2 VPN. In the layer 3, if I'm going to talk about, we have a GRE, we have a MGRE, we have a DMVPN, right? We are going to discuss with the IPsec protocol, as well as we have a GET VPN. So all these VPNs are comes in this one, layer 3. In the layer 2, we have a Q and Q tunneling. In the layer 2.5, we have a MPLS VPN. So our main focus is today is only on the GRE, right? Why I'm going to learn the first of all GRE? It's a foundation of the VPN. Foundation in the sense of what? For example, if this person wants to learn the CCNP, what is the foundation of the networking? The foundation of the networking, you must have a knowledge of the CCNP. That's a foundation, right? Without learning the IP addressing and subnet, you cannot learn any of the routing protocol. Same thing, if this person wants to speak English, right? What happened? They first need to learn the grammar. They first need to learn the alphabet, right? They first need to learn the grammar. They first need to know alphabet, right? If they want to speak English, right? Same thing, to go in the VPN, any VPN like MGRE or DMVPN, GET VPN, MPLS, IPsec, any of the VPN, you first need to have a foundation of the VPN, that is GRE. So I'm going to just implement the GRE, and by using the GRE, I'm going to achieve this topology. So this is the GRE I'm going to implement over there, and through the GRE, I'm going to achieve this topology. This one and this one. So GRE is the one of the VPN. How do I do that? I just need to go, as I told you that as I told you, this is my logical connection, right? This is my logical connection. This logical connection has a logical interface. This logical connection has a logical interface, and that interface is known as a tunnel. So I'm going to define this person. Hey, the tunnel you have this is the tunnel identification. You have a interface tunnel. After that, we need to put the identifier. After that, you need to put the identifier. If you see right now, interface tunnel 1, if you see what happened, I need to define this range of identifier. You can take any number from this range, right? And it's a
Sir,
locally significant.
can you please show the pre-config, sir? What is there on that box before you?
Nothing is there right now.
Okay.
Nothing is there. I'll just show you the how many ID you can create on the term on router number 1.
So there's no IP, there's nothing configured on the no SPF, nothing is there.
Nothing is there right now. I think so. IP is there. Nothing. Do swipe protocol summary. I'm gonna remove this thing all by 1 minute. Interface 0/0. I'll make it the no interface loopback number 1, no interface loopback number 2, and default interface 0/0. So nothing is there. Do swipe interface brief. Do swipe protocol summary. Right? Nothing is there. And do show interface tunnel 1. You can see I have this range of. You can take any number, it's a locally significant. So I can say that, okay, this is my tunnel number. Let me copy it. Yes. I can put it. So I can say that this guy has a tunnel number, maybe 1. I'm going to use for this guy interface tunnel 1, right? And for this is, as I told you, this is my logical interface, right? This is my logical interface. And every interface, that doesn't matter if the interface is physical or if the interface is logical. Every interface has a common thing. Every interface has a common thing. So I need to define the tunnel IP address of this guy. I can take any IP address. I'll go for the 192.168.101/24, right? Why I'm going to put the identification number on the tunnel? Because on a router 1 can have a multiple tunnel. For example, router 1 has this Delhi branch has a connectivity with the Bangalore. At the same time, this Delhi branch has a connectivity with the Calcutta as well as. This Delhi branch has a connectivity with the Mumbai as well as. So what I can do, I just need to put the identifier. Okay, this is the 1 is for the Bangalore, 2.4 is Calcutta, and 3.4 is Mumbai. But this ID is a locally significant. For example, if I'm going to use the ID 1 on the router number 1 side, I can use the router number 2 side, ID number 3. So can you see the same ID 1 from this side, ID 3 is from this side. This is the same tunnel interface, but ID is from one side, ID is from this side. So locally significant. It's not should be same. But it's recommendation to make a same, to make a easy troubleshooting, but it's not should be same, right? We can make a different one as well. It will not create any kind of issue because in the update we are not going to exchange. In the update we are not going to exchange this number. Now, what I can do, I'm just going to put the interface on 1. Then I need to define the IP address /24, and then after that I need to say tunnel source from where you're going to create a tunnel. Because I'm going to create a tunnel from which location. This should be a public IP addressing, right? I'm going to make a tunnel. This should be source, because when the packet is exiting from this interface, right? When the packet is exiting, this is the interface. Take example. This is the interface number 0/0, and this is the interface number 0/0, or 0/1 as well as. So what I'm saying that, hey, when the packet is coming tunnel source 0/0, or we can make a IP address as well as, because I'm creating my tunnel source when the packet is exiting from this interface, right? Because when the packet is coming inside the interface 0/1, it has to be send the packet from 0/0, right? When the packet is coming to the 0/0, I need to make a send the packet through the tunnel over there. This is my source of this one. You can make any different source as well as, but this is my source of the 0/0 that is facing to the WAN side, and that will be my destination. Will be what? My destination will be from here to here. So I can write the destination over there. Yep. on our own router. Destination will be 23.101. So from the source, I can write either in the source, I can put the IP address as well as, or you can put the interface number. So if you're going to just put the interface number, what happened? They will take the IP address from this interface. If you just put the interface number, they will take the IP address from this interface. But in this case, what happened? Once you define the terminal destination, you always need to put IP, because I don't know the what's the interface number of the router number 2, right? Right now, the same thing I need to do on this guy. On the same thing I need to do on this guy. I see the interface tunnel 1. I can go for the interface tunnel 10 as well as this is the 1, and I can use the 10. On the same time, I'm going to define the IP address will be 1 or 2. Same subnet, right? And then after that, is a tunnel source. Tunnel source will be, I can go for the 0/1, or either we can go for the 23.101. And tunnel destination, I need to go for the 13.101, and I say the exit now. This configuration I need to do on the router number 1. This configuration I need to do on the router number 2, right? So what happened? This is the tunnel 1 interface from this side. Interface tunnel 1. This side they have this tunnel. This tunnel I'm talking about, red one. This tunnel has IP address will be 101/24. Same thing. We have a tunnel 10 over there. This logical interface tunnel 1. They have IP address will be 102. And this tunnel will be a directly connected route for R1. So whatever the route, this is the route will be 192.168.1.0/24. This will be a directly connected for the R1, and this associated with the tunnel 1. Same thing on R2, this will be a directly connected route C192.168.1.0/24, and that will associate with the tunnel 10. That's identifier. So right now I just create, right? Right now I've just created by putting this configuration, right? By putting this configuration, we just done with this part. We just achieved this network, right? After doing this configuration, right? After doing this configuration, we have just achieved this part. So this part has IP addressing. We can see that. (192.168.101/24), because the tunnel that I have defined the IP address 101, and the same thing /1. Now after doing this thing, right? After doing this thing, what I can do, I need to exchange my this route to this person. I need to exchange my this route to this person, right? And how do I exchange? I need to enable the EHGRP. So now I'm going to enable the EHGRP. I say router EHGRP number 1, and if you see, I'm just going to put the which command 12.1.0/24. That is my tunnel interface and network node of some. Same thing on this guy, router number 2, 3.0 and 4.0. So can you see that in this EHGRP, that's we have achieved the overlay. I'm going to run this protocol on the overlay network, right? I haven't advertised this network, right? Because this guy is running with the OS web, right? So I can directly exchange my all information now after doing this configuration. After doing this configuration, what happened? After doing this configuration, this part of the doing, on this part of the doing, what happened? Now this router, Now this router is going to exchange the own information to the R2, and R2 is going to exchange the own information to the R1. Which information? This information. 10.101.0/24 and 10.1.2.0/24. Same thing on this side. This guy will be 3 and this guy will be 4. So now the R1 is going to say the own information to the R2, and R2 is going to say the own information to the R1. And how they will learn this information? They will just have an information like a 10.d. I'm going to learn the 10.1.1.0/24. 90 will be 80. Some metric will be there, right? And then after that, I'm going to learn this information from whom? 192.168.101. That is my neighbor, right? That is this guy. And I'm learning this information on the tunnel 10. That's my tunnel. This will be the R2 routing table. Because R1 is sending this information to the R2, right? So R2 has a neighborship with which person? R1 101. So I'm learning this information 101 on which interface? Tunnel 10. That is this guy. This person. Clear? So let's do this practical. If you see this is my R1, R2, and we have ISP. So this is my public IP address that I'm going to use over there, right? And for the reachability, I'm going to use the default route. You can use the OSPF as well. It's totally up to you, right? Let's go for the OSPF right now. So I'm going to run the OSPF. Right? So OSPF area 0. Area 0, this guy. And this should be same from the other side. So in the OSPF, what I'm going to do, I'm only going to advertise my public to just make a reachability. So that we have a reachability from here to here. That's it. Because we are making a VPN between this guy to the source will be this guy and destination will be this guy, right? So from this user perspective, this is the source and this is the destination. And from this user perspective, this is the source and this is the destination. So we just need to make a reachability between this guy to this guy. ISP R2. So what I'm going to do, first of all, I'm going to give the basic IP addressing on the WAN interface, right? So interface 0/0 that has the IP address will be 101/8, no shutdown. And we have some private network that's a loopback number 1/24. Interface loopback number 2/24. No, sir. Do show IP interface brief exclude on the side. Loopback does not have a MAC address, guys. Always remember. So we have this interface 0/0 that is a 101. And this is the loopback number 1 to 101. That's the LAN information. And loopback number 2, that's a 2.1. It's a 2.1. Okay, let's make it 10. According to the diagram, it has to be 10.1. All done, right? All good to go, right? Router number 2 now, this side. If it is show IP protocol summary, I don't have any protocol. I think so. We don't have. Yep. So do show IP interface brief. So can you see we have a 2.2.2 this interface configure, right? And we have a 2.0.0, 2.1. That is this guy, and 20.0. That is loopback number 2, right? LAN information. So if you do show IP route, maybe I have default out. So let's remove the default out because I'm interested to run the right now OSPF. Same thing from here. I think so on this guy also have a default. All good, no IP route. So everything is now normal. WR. On an ISP, if you see the configuration show IP interface brief, I just have a basic IP addressing. If you just take the routing table, I just have a directly connected route. On a router number 1, what I can do, I'm just going to provide the reachability between this guy to this guy, right? How do I do that? I'm just going to enable the OSP. Router ID, network, area 0, right? Router number 3, sorry, router number 2, router OSPF 1, route ID, network, area. This guy, I have advertised only the WAN interface. This guy, I have only advertised the WAN interface. On the ISP side, same thing. Area 0, network, area 0, and done. So just wait for this some time because OSPF will take some time to form the neighborship. So waiting state is going on. If you see do show IP OSPF interface brief, the wait state is going on, right? The DRA will be beta. So now I have a neighborship. If you see R1 is forming the neighborship with the 3.3.3, that is actually a R3, that's ISP. And if you see the do show IP root OSPF, we have this information. From R1, this user, I can ping this person, right? WAN interface, right? We have a good to go utility. Now what I can do, I'm just going to make a overlay network. How do I do that? I just say the interface tunnel number. You can take any number. I say the 1. After that, what happened? If you see do show IP interface brief, what happened? I just put this command interface tunnel 1. This tunnel is going to do, this command is just going to create a one logical interface. My status is up, but my protocol is down. So if you see do show interface tunnel 1, what happened? I have a lots of information over there, but we don't have any IP addresses configured, right? Not the source is unknown right now, and destination is unknown. So I just create the interface tunnel 1, and what happened after that? My one logical interface will be created. My one logical interface will be created, but they don't have any source and they don't have any destination. But the protocol that I'm going to use, that is a GRE. The GRE IP means what? It works on the protocol number, IP protocol number 47. GRE works on
That's the default, sir. I mean, we didn't configure anything, right?
nothing. I just create the channel 1. That's why.
Okay.
I just put the one command, just simple command. So right now we don't have any IP address. The first thing is that we need to define the IP address. What IP address I'm going to use? I can go for the anyone. I just go for the IP address will be 12.1, or we can go make it 12.1/24 because we have a router number 1 and router number 2. So we can have the 12.1, right? This guy. So now if you see do show IP interface brief, we have a IP addressing on this guy, but still down, and it do show interface tunnel 1. If you see, we give the IP address to this person, right? 12.1, right? But still unknown. I don't know from where to where. I don't know from where to where I need to form a tunnel. And if you check the routing table right now, after putting this IP addressing, I have a routing information. Okay, my tunnel is down right now. That's why it's not saying. Once the tunnel will be up, interface will be up. That's that after that it will show. Because as we know, after the putting the node shutdown, the interface will be added in the routing table, right? So right now it's not saying. After that, it will say. So now after that, we need to define the channel source. Channel source will be this guy 101.1, and channel destination what? Can you see that after putting this command, still my tunnel is down? But once I'm going to put the tunnel destination 2.2.2.2, what router 1 is going to do? It is going to perform the destination lookup for the this guy 2.2.2. Do we have a reachability? Do we have a route for this guy? Yes. If you have a route, then I'm going to up this interface. If you have a reachability, then I'm going to up this interface. Now, if you see, according to the R1, do show IP route, I'm going to add this route in my routing table as well as now. Where is that? Yes, tunnel 1. And if you see do show interface, we have what my tunnel is up now. We have an internet address over there. At the same time, we have a source and destination. Same thing I need to do go on a router number 2. I need to see the interface tunnel 1. Or we can take any number. I can go for the internal 100 as well as, right? I need to define the IP address. They belong to the same subnet, right? Make sure that 12 or 2. They belong to the same subnet. No, don't need to do my no shutdown. Do tunnel source. Do one thing. Do debug IP routing. Tunnel source will be I can use my 0/0. I can use, right? So here I have defined the interface IP, and here I'm going to define the interface number. And now tunnel destination, I need to make a tunnel with the 101. So again, it will look up the routing table information. Do we have a 101? Yes. If you have, my tunnel will be up. And if my tunnel will be up, I'm going to add this route in my routing table. And how they are associated? It's associated with the tunnel 100. Right? So now if you see, do show interface tunnel 100, what happened? All good? So now we need to exchange. If you see the router number 2 as well as do show IP route 100. So on this guy, I have created the 100. On this guy, I have created the 1. But they belong to the same domain, same broadcast domain, 12 or 0. What is the next thing that we have to do over there? I need to go on the router number 1. I need to enable the EAGRP routing protocol, because my goal is what? My goal is I just need to provide the connectivity between this LAN to this LAN, right? So what we can do over there, I need to run the EAGRP on a router number 1, router EAGRP number 1. And in this router EAGRP, I'm only going to advertise my tunnel interface, right? I'm only going to advertise my LAN information. Same thing on router number 2, router EAGRP number 1. I'm going to advertise my tunnel
Sir,
interface.
I think
Yeah.
you advertised the wrong IP on R1, sir.
Acha, yeah, I think so. I need to advertise the.
Yeah, 2.0 is not there. Yeah.
Exactly right. It's a 10.0. Done. So now R1 also I've done, on R2 also I did the same thing. So now see, once I have enabled the GRP on the tunnel interface, they are forming the neighborship through the tunnel. They are forming the neighborship through the tunnel. R2 is saying that, hey, I have a neighborship with the 12.1, that is this guy, and my interface that I'm going to form is the through the tunnel. At the same time, I'm going to make a neighborship, and I'm going to make a logical connection, that's adjacency. And I'm going to add this route in my routing table. I'm going to add this route in my routing table. So if you see on a router number 2, show IP EHGRP neighbor. I have a neighborship right through the, and I'm going to learn all the routes. Show IP route EHGRP. If you see, I will just put the show IP route. What happened? I'm going to learn all this information through the tunnel. Every single thing I'm learning through the tunnel. So does R3 has any route ISP? See, ISP does not have any idea of the customer route. It's ISP routing table. They don't have any information on the customer. We are exchanging all this information right now like this. We are exchanging this information like this. like this. So ISP does not have any ad. That's the meaning of VPN. VPN is what it is used to provide the connectivity between the two or more sites over the public network. So we have a logical connection, right? This is the logical connection that we are making between site to site, right? And over this tunnel, I'm going to exchange my all the routing information. This is my overlay. So now if you see, if your underlay is working fine, try to understand if your underlay is working fine. If your underlay is working fine, you will have an overlay. But if you have an issue with the underlay, then overlay also goes down. Same thing if you just have a look over there right now, R2, or we can say that go on R1 as well as do show IP root EHGRP. I'm having all information I'm learning from my Bangalore branch. I'm posing the Delhi branch right now. I'm learning all this information through the tunnel. But what happened? Take example. If this interface goes down, if this goes down, wait for some time, this will also terminate. If this guy is going to terminate, this guy is also going to be terminated. Can you see my neighbor has done? So my overlay, right? Can you see the state? My tunnel is also down. My overlay network is totally relying. My overlay network, this guy is totally relying on which person? On the underlay. Overlay is totally relying on the underlay. If your underlay is working fine, you will achieve the overlay. If you have any issue with the reachability of the public, right? If you have any issue with the reachability of the public, you cannot achieve the overlay. Even if you are doing the GRE, you are doing the MGRE, if you're doing the DMVPN as well as, even in the gate VPN as well as, say everything, even the IPsec you're doing over there. So in IPsec, what happened? We are going to make a side-to-side VPN, right? Even if we need a reachability. Reachability is must be there. Underlays should be present. Yeah. Now make a no shutdown on R3. Once I up this interface, if I'm going to up this interface now, you will have a automatically you will get the overlay.
On the underlay, you only publish the public IPs, no, sir?
Yeah,
On the network.
only I'm public the public IP. This guy. In the
All
OSPF,
the
I'm going to this guy and this guy. That's it. And in EHGRP, we have enabled the this person and LAN information. This person and LAN information. So EHGRP, I'm going to run with the R1 and R2. Whereas OSPF, I'm running between all this router. OSPF, I'm also involving in the ISP.
when you're running OSPF, sir, on R1 and R2, so you are running it per interface, or you just doing a
It doesn't
network?
matter. You can enable the per interface or you can advertise the network. It doesn't matter.
Because there is a tunnel interface, no, sir. So by default, when you advertise OSPF network statement, will it apply to the tunnel interface also,
So
or
in
no?
a network stream, what I did over there, if you see, I only advertise the 1.0/8, right? So 1.0/8 is only 1.0/0 interface, right? Not the tunnel. Tunnel has a 12.1.
Okay. So in case you put a network 0.0, then basically it will apply
Yeah,
across to the.
yeah, exactly. Then
Okay.
100%.
Can you then do a show run section EAJP also, sir, once?
Yep.
One dot zero, 10.0. And on tunnel interface, you configure 12.1 and 12.2, correct?
Yeah, that is this guy 12.1. This guy 12.1 and 12.
Okay. So once you shut ISP F0/1, even the EIGRP goes down. I was getting confused. Why, when you shut the ISP, no, sir?
If I'm going to tell me one thing, what is the use of this command? Show an interface tunnel one. Destination correct. The destination 2.2.2. R1, I'm
Oh,
saying the
okay.
destination 2.2.2. So the
Okay, okay,
2.2
got it.
must be reachable by the R1, right?
Perfect, perfect. Yeah, I missed that part. Okay, yeah. So basically, your source and destination are the connectivity of the underlay.
Yep. So that's
Okay.
must be reachable.
Yes, yes. Thank you.
So now if you see, if I'm going to send any packet, try to understand, I see the ping 192.168.2.1 from R1. On R1, I'm pinging 2.1, right? So what happened in this case? So router 1, sorry, is there, right? So if you see show IP route, I have 2.0. So because this is the line information that we are accessing through the tunnel, right? Right. So if I say the ping, see, if I say the ping 2.1, what happened in this case? Destination will be what? 2.1, right? So if the destination is 2.1, in that case, what happened? It is going to look up the routing table. Hey, do we have 2.0 in my routing table? According to the routing table, he said that I have a 2.0/24 and I need to forward the packet home. 12 or 2, right? I need to forward the packet to the 12 or 2. And how do I get to the 12 or 2? Tunnel 1. So if you just see the tunnel 1, so interface tunnel 1, the tunnel 1 is saying that, hey, you have to use which IP address as a source? 12.1, right? And what will be the destination source of the public? The public will be source will be 101. Destination will be what? So this is the source, destination, source, destination. So this is my what? Outer header, and this is my inner header. In between, we have a GRE. So we can see that IP, GRE, and IP like this. So this IP, this header is the outer header. That's my public, right? And this is my private, the LAN. So if you see right now, if you're just going to capture this link, see ping 2.1. You see source is what? The same information there, right? Source is 2.1, right? 12.1. Destination is what? 2.1. That this guy. And then after that we have GRE, and after that we have a destination 2.2.2 and source 101. That's public. So this is my public header, right? This is my public, or we can say the outer header, and this guy is my private. We can say inner header, and after that we have a GRE encapsulation. In between we have so we can say the IP over IP GRE is there. Encapsulating your IP packet over the IP. That is done by the GRE. GRE stands for Generic Routing Encapsulation. Encapsulation means what? Cover something. So this was my thing, right? That's why I'm going to cover right by this guy. I'm going to cover. So this was my actual packet, right? This is my original header, right? This was my original header. I'm going to cover this original header with this guy. Encapsulating, right? I'm going to encapsulate my packet. I'm just going to encapsulate my IP over the IP. So now if you see, this is the GRE 47 over there. This guy. I'm sorry. In this IP protocol, which has to be 47, right? So this guy is saying that, hey, when the packet is coming to you, source MAC over there, distance MAC, so you need to forward the packet to the IPv4, right? That's a layer 2 information. On the packet is coming to the layer 3. The layer 3 is in the source IP, distance IP. I need to forward the packet to whom? GRE. So it will forward the packet to the GRE, right? And once the GRE is receiving, then it will encapsulate the new packet, source and 12.1, destination 2.1. And now he's sending the packet. Let's forward the packet to whom? ICMP. And then after that, we have a ICMP header. All the data information we have. So the first packet is coming to the type IPv4. Forward the packet to the GRE. It will forward the packet to the GRE. Once the GRE comes in the picture, it will forward the packet to the layer 3 now, and layer 3 single layer will forward the packet to the ICMP, and now we have a ICMP data. Same thing. If you just have a look, if you see the hello packet, my hello is extending like this. Can you see? This is my hello packet. EGRP, this is the EGRP. EGRP is running on the terminal interface, right? So how they even the terminal, my hello packet is going to be encapsulated, right? Because I need a public utility, I need to encapsulate my packet. That's the meaning of GRE encapsulation protocol. So in this case, if you see right now, the source is what? 12.1, right? Because I didn't define any source over there, right? That's why if you define the source, in this case, what happened? The source will be changed now. It's a 101. My public, so my LAN information, LAN to LAN communication I'm doing right now. So my LAN to LAN communication is happening. The difference is in front of you. If you don't mention the source, it will take the terminal interface. If you don't mention, if you do the mentioning, right, then your actual IP address LAN to LAN. This thing you can achieve through the GRE. All good?
So now basically when you're doing an IP over IP, so your source is 12.1 and your destination is 2.1 or 2. Yeah. So basically when somebody is trying to interpret a packet in the middle, the man in the middle.
So
So now,
therefore, so right now
okay.
what happened? Right now we are just exchanging a LAN information through the tunnel. If you're not, but still my packet, if you see my data is traveling in the clear text. Can you see that my data is still in the clear text format? If you want to secure this data, then you need to implement the IPsec. That we'll discuss later on. Not now.
Okay, so this is still vulnerable, correct?
Yeah. Still, we are not going to see. We are exchanging my routing LAN information through from here to here directly. So in this case, what happened? R3 does not get any idea of the LAN information. They don't have any single information.
So when you're saying encapsulating, what exactly? So basically, it's
We are just encapsulating my this header with this guy. That's my source and destination. This person. So let's see how the encapsulation is happening. Try to understand this thing. This guy is sending the packet, right? This guy wants to communicate with this person. Okay. So in this case, what happened? Source will be what? Destination will be what? Right? Source, destination, GRE. When the packet is coming to this guy, what this guy is going to do? This guy is going to encapsulate this packet. So this is my actually original header, right? Or we can say that inner header. Right now it's the original header, but when this packet is receiving on this interface on 0/0, on the 0/0, what happened? I make a VPN between this guy to this guy, right? So what happened? Now this packet is going to be encapsulated with 10101, that is source, and distance will be this guy, 202.2.2. So in this case, what happened? Now this guy will become the inner header, and this guy will become the outer header. So when the packet is coming to the ISP, what ISP is doing? ISP is going to look up for which person? ISP is going to look up for the outer header, because ISP does not have any idea of this way. Exactly. Now, Swami, clear?
Yes, sir. So when you do a show IP route 192.168.2.1 on R1, sir, can you just?
Yeah, it's associated with the this guy. You see, tunnel, wire tunnel.
Show IP route 192.168.12.2 when you do, sir? What is the?
That's my directly connected, right? Wire tunnel.
Okay. Okay.
All good. Hope you guys this GRE concept is clear to all of you. If you have any questions, you can ask me. I'm done. Any question you can ask. Sorry. It's clear. So guys, we need to find the GRE issues, right? Then I'm going to discuss with the MGRE, and then I'm going to discuss with the DM. I'll tell you one thing: in the market, we are not going to use the GRE. Even we are not going to use the MGRE. But to understand the DMVPN, you must have a good knowledge of the MGRE and GRE. Yeah, but basics. We are not going to use the in the market. We are not going to use the GRE and MGRE. But wait, again, to understand the DMVPN, you must need to have a GRE and MGRE. And I'm telling you, in the CCIE lab exam, this DMVPN is major role play. Major role play. The DMVPN comes in the major role play in the CCIE interface. The complete whole structure you implement on DMVPN. Like you can say that if your DMVPN is not working in your exam, DMVPN, MPLS VPN, 100% you will fail. 110%. No one can pass you without DMVPN and MPLS. No one. Doesn't matter you have implemented all the IPv6, BGP, OSPF, ESGRP, HSRP, spanning tree, VLAN, everything you have configured it, right? Multicast event, quality of service event, right? But if your DMVPN is not working, you fail. That's the role of DMVPN. DMVPN is most important. All good. Okay, guys, then see you tomorrow. We'll do the MGRE. Okay. So before do one thing to do this practical and try to find the issue with the GRE. You can do one thing. You can make a one site over there, and that site look like this: ISP, and then router now 4, and make this guy as a branch in Chennai, right? And make a connectivity like this. Make a tunnel between like this, and make a tunnel like this. Full mesh. Yep, you have to like this as well as. So how many tunnel? Tunnel 1, 2, 3. Okay. Okay, guys. Bye bye.